Okay, so let's go ahead and get started. Notes. 11:17. Okay, we're talking about, first of all, ratios. Now, this is more algebra based. If you think of a ratio, Jeremiah, make sure you're muted, please. Okay. It looks like a fraction. Okay. But a ratio is a comparison. Is a comparison of two things. Okay, guys, make sure your sound's muted, please. If we were talking about just kind of a regular comparison, if I said I have like 3 dogs and 4 cats, I could write that as a ratio of like 3 to 4, or 3:4. Okay, that's if I wanted dogs to cats. I don't actually have that many dogs and cats, but a proportion is 2 ratios. Okay, remember, ratios are comparisons that equal each other. 2 ratios that equal each other. Sometimes I'll pause and make sure everybody's writing okay. So if I have the proportion 1/2 equals 2/4. How do we know that's true? Give me an idea. What do you think?
Because if you simplify 2/4, you get 1/2.
Okay, good. I can simplify this. I can divide 2/4 by 2, and I get 1/2. Let's see, got a couple other ideas from the chat box. Good. Good. 4 is half of 2. Okay. So I can either multiply this side by 2/2. I can divide the right side by 2/2. Or there's a third option, which we like, and that is we can cross multiply. Because if I cross multiply, 1 times 4 is 4, and that equals 2 times 2, which is 4. And this is the basis of what we're actually doing today, is the cross multiplying. I have 2 ratios, 2 comparisons, I make a proportion, okay? And we're going to be able to solve for variables. So our whole premise is something like 6/x is equal to 3/5. Okay. If I were to cross multiply that, like different colors. If I were to cross multiply, okay, so first we're going to cross multiply and then solve. Cross multiply and solve. So the 6 times 5, and I'm going to write it out so we can see what we're doing, and then 3 times x. But most of us would just write 30 equals 3x. So 30 equals 3x, divide both sides by 3, we get 10 equals x. And you're done. Okay. But don't forget, or please remember, that denominators hold on, I spelled that wrong. Yeah, my hand and brain don't always work together. Denominators cannot equal what number? It's a number I can't divide by.
0.
Good. So for example, the 5 will never equal 0. But the x could equal 0 if x were 0. Okay. So we know if that problem had an answer of 0, we wouldn't be able to use it. Okay, good. Okay. So here's an example. We'll just jump right in. Over x minus 5 is equal to 5 over 2. So here's the important part, one of the important parts about this problem. We need to put all parts with a plus or minus, but to put it in parentheses. We need to put it in parentheses. The reason being, because when I cross multiply, I may, if I don't do that, I may lose an important number. So this is what I mean. I multiply 2 times x plus 3. Well, if I only wrote 2x plus 3, I would lose the fact that I need to distribute the 2 to the 3. That's why. Then I cross multiply. I have 5 times the quantity x minus 5. So we just cross multiplied. Please notice, this is important, that there's no more fractions. The whole purpose of cross multiplying was to get rid of the fraction. Okay, so now we can solve. So distributing the 2, we get 2x plus 3. And what do I get on the other side?
5x minus 25.
Good. So distributing the 5, we get 5x minus 25. If you remember way back from the first week, solving equations, I like to start with the x's to keep it consistent. So I'm going to subtract 2x. So I've got 3 is equal to 3x minus 25. And then we move the numbers to the other side. Okay. So I'm going to add 25 to both sides. Don't forget when you move it across the equal sign, you have to change the sign. So this cancels.
Wouldn't the 3 on the left side be a 6? Since it's 2 times 3.
Yes, thank you. Awesome. Thank you for catching that. Wait a minute, that doesn't look like it did earlier. Awesome. That's why I had the 31. 31 is equal to 3x. Guys, I am not perfect by any means, so if you think I made a mistake, please say so. I'm dividing both sides by 3. We have 31 over 3 equals x. I would prefer that you leave your answers as an improper fraction, but if you prefer, you can make it a mixed number as 10 1/3, or even a decimal, which we usually don't do decimals right here, of 10.3. Okay, but I prefer the improper fraction. Questions on that one? Okay, so notice this for a second. What is the value that's going to make this denominator of x minus 5 equal to 0? What's the value that's going to make x minus 5 equal to 0? Any ideas? You can put it in a chat box if you prefer. Okay, Emery's got it, good. Okay, Ace has it. Okay, Few people don't know. And again, that's more like you don't remember. You probably saw it in algebra. But think about it this way. If I want to know what makes x minus 5 equal to 0, because that is the restriction, it's the only number that x can't be in this whole problem. Okay, we're going to say, if I solve this, I'm going to add 5 to both sides. So x equals 5 is a number it cannot be. So can't be, because it'll make it equal 0. So our only restriction is that x cannot equal 5. It could equal anything else in the infinite universe except for 5. Because then we'd be dividing by 0. But honestly, I will tell you, I don't really do that to you guys. I really don't ask that, but I need you to be aware of it. If for some reason you had an answer of x equals 5, that would be the answer you'd have to throw back. It doesn't work. It's called extraneous. Okay, now you may remember that, you may not. It's okay. Now I had some questions last period. It's like, well, what about the x plus 3? Okay, well, if you look back up here, it's the denominators that can't equal 0. The numerator can equal 0. So we don't need to worry about the x plus 3. We only need to worry about the x minus 5. Okay. And we only need to think about a restriction if there's a variable in the denominator. If there's not a variable in the denominator, there are no restrictions. Okay. But if that didn't make a lot of sense, don't worry about it. Okay, because we don't go over that a lot. Okay. So why did we talk about proportions and being able to cross multiply? Because we're talking about proportional lengths. Proportional lengths. Which means it's just a comparison of the lengths of sides. Proportional lengths. Okay, so we're going to draw this triangle. Okay. This is not necessarily a mid segment. It does not have to join the midpoints. But these do have to be parallel. Okay. We're going to talk about this more in terms of parts than lengths for a minute. The book labels all of these parts with letters, and the letters get really confusing. I want you to have the ideas or the concepts more so than the letters. Okay, so here's what I mean. We're going to call this left side, side A. Okay, we're going to call this side A. We're going to call this side B. We're going to call this part the large part because it looks a little bit bigger than the small part. That's the large, this is the small. It could have been reversed. Okay, you could call it the top or the bottom. Okay, top or bottom would have been the same thing. And here's the whole side. The whole side. So if this was 10 and that was 5, the whole side would be 15. Over here, we're going to have the same idea. We have the large side, we have the small side, and we have the whole side. Okay. So we're going to use it's called the triangle proportionality. It's like personality, but proportionality. Okay, theorem. Triangle proportionality theorem. Honestly, I'm more concerned about you being able to use it than able to tell me what it is. But if you just think about it as we have triangles and the sides are proportional. If these are parallel, the sides are proportional. Okay. So what that looks like is I'm going to give you numbers and we're going to have to solve for x. But I want you to see the different proportions that we can set up in order to do that. So I can take the large part of A over the small part of A. So I could take the top over the bottom, just like a 1 over a 2. Just make it a fraction. And I could set that equal to the large part of B over the small part of B. So if you think about it, it's going to be this number over that number equals this number over that number. So it's just think about it as a fraction, two fractions that equal each other. The other, so we're just going to make comparisons. The other one that I can use is the small part of A over the whole part of A. I can set that equal to the small part of B over the whole part of B. And I could do the same thing with the large part. I can do the large part of A over the whole part of A is equal to the large part of B over the whole part of B. Okay. Notice it's consistent. It's large over small equals large over small. Small over whole equals small over whole. I can do the large over whole equals the large over the whole. It's all about consistency. I could even flip these and go small over large, whole over small, and whole over large. And you get the same exact answer. They are proportional. Their proportions will be equal. The other thing I can do is, and we probably won't do this much. There are reasons to do it, but probably not right now. Okay, we can go the small part of A over the small part of B is equal to the large part of A over the large part of B, which could equal, so all these could be equal, the whole part of A over the whole part of B. So notice the consistency. Small over small equals large over large. A over B, A over B, A over B. I know that's a lot of abstract things right there. So what we're going to do is I'm going to actually draw a triangle. And we're going to put some numbers with it so we can see it and see it in action. Let's do that. I'm going to call this part 2 and 1, 6 and 3. So what would the whole part of the left side be?
Whole A.
Yes. What's the numerical value? What number?
3.
3. Good. And I had a couple people put that in the chat too. Okay. And what would the whole side of the right side be?
9.
9. Okay. So now let's look at some of these proportions and so that we can identify and recognize that really is true. Okay. So like this one, the large part of A over the small part of A. So I've got 2 over 1. 2 over 1. And we're going to make sure that that's equal to the large part of B over the small part of B. So 6 over 3. Are those equal?
Yes.
Yeah, they are. Because 2 over 1 is 2, 6 over 3 is 2. Okay. We can do the small part of A over the whole part of A. So that would be 1 over 3 is equal to this small part of B over the whole part of B, 3 over 9. Okay. We could also do the large part of A over the whole part of A. We could do the large part of B over the whole part of B. And if we really wanted to know if they were equal and we weren't sure, we couldn't see that they were equal, we could always cross multiply. So 2 times 3 is 6, 6 times 1 is 6. Those are equal. 1 times 9 is 9, 3 times 3 is 9. Those are equal. 2 times 9 is 18, 6 times 3 is 18. So they are equal. And last, if we want to confirm this part up here, the small part of A or small part of B, so we could go 1 over 3. We could go large part 2 over 6, or whole over whole, which would be 3 over 9. Oops, 2 over 6. Well, I just don't like those 6s, huh? And they all reduce to 1/3. Okay, so this is the whole premise of why we're going to do what we do. We're spending a little bit more time on the triangle part, because once we understand the triangle part, then the other two examples just make a whole lot more sense. Okay, so let's do an example. I'm going to tell you, I really like the fact that we have 2 days together now, because one day we get to talk about the content, we get to interact with it, we get to ask you more questions, we get to take it a little slower. And then the next day we get to actually work on the assignments together. So I'm excited about that. So here's a triangle. I have to tell you that they're parallel. So this is 33, that's X. This is 27 and 18. Circle that to the new one. Okay, so write down what you think a good ratio would be to solve for X. Keep it really simple. Write down what you think it would be. I'm going to give you a minute to do that, and then I'll tell you some of the options that you have. So keep it really simple. Don't make it complicated. Okay. So let's see if you got any of these, okay? If I want to make it just left side equals right side, I would use top over bottom. It just makes it look like our fraction. So this would be 33 over X would be equal to, what would it be on the other side?
27 over 18.
27 over 18, okay? So that's one option. And that's generally the option I use because I like to keep it consistent. It just like, here's a fraction, a ratio, here's a ratio. I'll set them equal to each other. Yes, Ian, that is the answer. Okay, so then, or we could have said 33 over 27. This is just to kind of get options. Equals X over 18. That was another option. Here's one that we don't usually do very often, but it is available to us. And that is like this part over the whole, this part over the whole. So we could have said 27 over, that's 45 together is equal to 33 over. If you want to combine these, do I need a symbol in the middle? in order to represent the whole side, I'd have to go 33 plus x. 33 plus x. It would not be just 33x because if you don't put the symbol in between, that means multiply. You have to indicate that you're adding those together. Because if this were 10, you'd be going 33 plus 10 to get the bottom number. So yes, it does have to have a symbol, but we're not going to use that one. We're just going to keep it simple and we'll use this first one. Okay. So cross multiply, I have 27x is equal to 33 times 18. And this is why I said have a calculator, but I don't have a calculator handy. I mean, I have my phone, I could do that. But I do kind of a mental math type of thing. And where I will divide by 27. Actually, let me back up before I do that. Because I totally forgot to say something here. When I'm actually doing these, I like to reduce if possible. So I do 33 over x is equal to, and I would reduce these by 9, and I would get 3 over 2. Okay. So now when I cross multiply, I have 3x is equal to 66. And dividing by 3, I get x equals 22. And some of you got that already. Okay. 594, thank you. Okay. That's too much work for me. Anyway, if I cross multiply here, I'd reduce this first to 11 over 9 equals x over 18. I just wanted to show you that we do get the same answer. So we go 9x is equal to, here's where I do it this way. And you don't have to do it this way. If you don't understand it, it's fine. Then I would divide by 9. And if you want to know more about it, we can go over that tomorrow. But I go 9 and 9 goes once, 9 there goes twice, and 11 times 2 is 22. Because I know that on my calculator, I'm just going to multiply these together to turn around and divide it again, but I get the same exact answer. Questions on that? Okay. We are going to do 2 more before we move on to the next. These are different types, but all dealing with your triangle. Okay, so draw this one. So these would be parallel. That's the whole premise. If these aren't parallel, then this does not work at all. I'm going to tell you that this side is 14. The small piece is 4. This is x, and that's 6. So what I want you to do is write down a proportion, an equation that you think we could use to solve for x, and then put done in the chat box. Write down how you think we could solve for x, and then put it in the chat box. You don't actually have to put what you wrote. You can just write done. Just write it down. I'll give you just a couple minutes. And if you're not sure, you can put IDK because I need to hear from everyone. Like 30 of you. Okay. Okay. I need a few more. And I'm going to start. Hold on, people. Okay. A lot of you wrote something because you said done, and I'd say probably a good third of you are I'm not sure or I don't know. Okay, so that's fine, and that gives me the feedback that I need. Okay, remember how I said we're going to look at this as a left equals right. Okay, a left equals right. Well, I need two numbers here. Can I find that top number that I'm missing? Is that easy? What would it be?
10.
Yeah, it'd be 10. And I go 14, take away 4, and I would get 10. So now it might make a little bit more sense, and that we can go top over bottom equals top over bottom. So all we're going to do is we're going to make it look like a fraction, and we're going to set them equal to each other. So I'm going to say 10 over 4 and x over 6, and I'm going to say equals. Those will be my fractions. So 10 over 4 is equal to x over 6. So if you said, I don't know, or I'm not sure, did that help? Put yes or no. Okay, good. Nice. Awesome. Okay, so that's what I mean by keep it simple. Left equals right, top over bottom. There's your fractions. Okay, so good. I'm really glad that helped. So let's reduce this just because I like less work when I multiply. So reducing by 2's, I get 5 over 2. It's x over 6. Cross multiply. So 5 times 6 is 30. 2 times x, 2x. Divide both sides by 2. We get 15 equals x. Okay. Here's the next one, the last one of this type. And it's kind of upside down. So there's my two parallel parts, which just means the sides that connect the parallel parts are the ones that are going to be proportional. So I'm going to tell you this is 20, this is 8, and no, my drawings are never scale to size. So this one is 15, and this one's x. You're like, and I can hear some of you now going, but that doesn't look like the last one we did. I get it, I know. That's why I'm giving you the different examples, okay? So think about it this way for a second. Okay, I can kind of angle it this way so that we have more of a left and right, okay? If my variable is the whole, then think about going back to the last page, how we can do small over whole or large over whole. And maybe that would make my problem a little bit easier. So if I do large or top, okay, we can do top to whole. So I can do top over whole, left and right. So this time the top is 15 and the whole side is x. What would that look like on the right side? What's the top part and what's the whole?
20 over 28.
Good. And several people are putting that in the chat box. Okay, so the top part is 20. So this is the top. This was the top. They have to correspond. Okay, and the whole, well, we just add them together and get 28. Okay, so this would be 20 over 28. Okay, move my paper back. Okay. So keep it simple. If you're given a whole value and you can't just subtract them to get the other part like we did up here, if that's not an option, then we can go top to whole equals top to whole, top to whole. Okay. Sometimes what you'll see me do is actually write what my fraction will look like, which is top to whole, and then I do left to right. Okay, so reducing, I get 15 over x is equal to, reducing by 4, I get 5 over 7. Okay, cross multiply, I get 5x is equal to 15 times 7. And dividing both sides by 5, that goes in 3 times, so x equals 21. Yep. Yeah, I'm not sure how you got 18, but do you see it now? Yeah, could be. Yeah. So 15 over x, 20 over 28. Other than that, it's just multiplication and division. Okay, any questions on those so far? Okay. Next part. This is really, really similar. I'm only going to do like one example. So I'm going to give you 3 parallel lines. And 2 transversals. Okay. 3 parallel lines and 2 transversals. Going back to, if the lines are parallel, then the parts are proportional. If the lines are parallel, the parts are proportional. So if lines are parallel, parts are proportional. Okay. So if I give you the parts, this would be x minus 5. This would be 8. This would be 5, and that would be 4. We're going to do the same exact thing that we did before. Let's keep it left equals right. Like left equals right, and make your fraction. So left equals right, and make your fraction. Okay, so write down what you think it would be. Write down what you think it would be. Okay, so let's see if you were right. I'm going to use top over bottom. Equals top over bottom. Just keep it simple. Okay. I know where I think you got the 10. Yes. So we do x minus 5 over 8 is equal to 5 over 4. Okay. Notice, just kind of putting this out there, there's no variables in my denominator. There would be no restrictions on this answer. Okay. No variables in your denominator, no restrictions. Okay. So don't forget to put that in parentheses, because when we cross multiply, I get 4 times x minus 5 is equal to 8 times 5 I'm gonna write it out. So distributing, I get 4x minus 20 is equal to 40. And adding 20 to both sides, I get 4x is equal to 60. Dividing by 4x equals 15. Okay. And I had 3 students that told me my answer was 10. Okay. And I think what they saw was that 4 times 2 gave me 8, and 5 times 2 gave me 10. But that doesn't mean this is 10. It means that that equals 10. So you have to actually add 5 to get 15. So, but I see where you went with that. Okay, good. So you have to, does that seem, I wouldn't say easy, but does that seem logical? Does that seem like it's okay, you get it type of thing? So let's hear a yes or a no or not yet. So are we okay with that content? Okay, yes, no, or not yet. Okay. Okay, good. I'm glad the examples are helping. Okay. Okay, for the most part, good. The thing that I would just say is, keep it really simple. Left equals right, but top over bottom when you can. When you can't, think about the whole side and do top to whole or small to whole. Okay. There's still several people that haven't responded. I'm going to go on, but we're going to take inventory soon. Okay. So here's this third type of proportional problem that we're going to see today and last. So we're going to be given a triangle. And we're going to be told that this is an angle bisector. This is going to equal that. Okay. This angle equals that angle does not mean that this part equals that part. Not at all. This is not a median. Not a median. A median would make this part equals that part. It is not that. Okay. So, but because of the angle bisector, the ray, remember a ray, the thing that divides the angle, okay, divides into proportions. Now, think about this for a second. Proportions automatically mean equal. Proportions automatically mean equal. So let me give you an example. This x, this could be 15, 45, and 25. So make sure that you got it written down. Okay. So here's what I would tell you is to make this into the 2 triangles. Okay, so I'm going to have you separate your 2 triangles. And there's your fraction. Okay, you'd have 1 triangle equals the second triangle. And make your fraction. So we would go x over 15, or the side over the bottom, it's the side over the bottom. So x over 15 is equal to 45 over 25. And solve. That's it. Once we understood the idea behind the proportions and how to set them up, it applies to everything. Okay? So reducing this side, x over 15, reducing by 5, I would get 9 over 5. Okay, good. Yes, that would be the answer. If you can see, without solving it, okay, if you can see, or sorry, if you can see without cross multiplying what x is, put yes in the chat box for me. I'm just kind of curious. Okay. Some students are able to see the pattern. This is why they like algebra a little bit more than geometry. Okay, and I get it. Okay. Without cross multiplying, are you able to see what x would be? That's my question. This only works if there's an actual pattern. Okay. And you don't have to. I'm not telling you you have to see it. Okay. So some students see that it's like, okay, 5 and 15 have a relationship. 5 times 3 would be 15. So that means the same relationship has to happen on top. So 9 times 3 would be our answer of 27. Okay, but you don't have to. So I can go 5x is equal to 9 times 15. I can divide both sides by 5. Okay, and I would get x equals 27. And you're done. Okay. You don't have to see that and, okay. This will only work if these go in evenly. If that were a 4, you wouldn't have a pattern. You'd have to cross multiply, okay? But, and if you do see it, that's fine. Remember, you have to show work. This is showing work. The x over 15 and 9 over 5 is showing work for me, and then you can write 27, I'm fine. Okay, so let's do another one. They have to tell you that that's an angle bisector. So we'll have x, 12, 18, 24. Okay, so go ahead and write down what your fractions would be. One fraction equals another fraction, write it down. When you're done, please put done in the chat box. If you want to solve from there, you can. I just want to make sure everybody has what we call think time. Okay. Yes, Hayden, no problem. Go for it. This is why I've made the chat box like you can only chat to me, because you don't have to worry about other people seeing what you're typing and yeah, things like that. Okay. Okay, good. Good. Okay, one more. Good. And a few people that hadn't been responding. Good. Nice. Okay. So if we want to keep it simple, make it one triangle equals the other triangle. Okay. And then use this as a top over bottom equals top over bottom. And write it down. So x over 24 equals 12 over 18. Are there other options? Absolutely. Okay. And you'll know your option was right if you get the right answer. Okay. So let's go ahead and reduce this one. The answer in the chat box that you just put in is not quite right. Let's try again. So x over 24, reduce these by 6. You get 2 over 3. Okay, so cross multiplying, I get 3x is equal to 2 times 24, which would be 48. Okay, dividing both sides by 3, you get x equals 16. I really like being able to do examples and getting input and feedback as we go. And if we were in a classroom setting, we would have been doing this all along, okay? You can flip it and should still be able to get the right answer. Okay. You could have said 24 over x is equal to 18 over 12. But yes, you have to flip it consistently. So if I do bottom over top, okay? But you can't mix it and go 12 over 24 equals 18 over 12. You got to keep it consistent. And I'm all about that, guys, honestly. So top over bottom equals top over bottom. Okay, awesome. Okay. This one's a little tricky, so be patient, okay? Be patient. Be patient with you, with yourself, and with me. So, okay, angle bisector. This would be 10. This would be x. This would be 20. But I'm not going to give you this one. I'm going to give you the whole thing. Give you the whole thing. Okay. But you might be a little freaking out right now, but it's like, but I need that number. I need that number. Well, what do you think we might be able to put in its place? If you think you know, go ahead and put it in the chat box. If you don't know, that's fine, but we're going to talk about it. But put what you think. Okay. Okay. Yes, we want to do the top over whole equals top over whole, but oh no, we can't do top over whole because the whole is the same thing for both sides. Okay. Yeah, we do want, we're not actually going to be able to put a number. We're going to have to be able to put an expression. Let me ask you this. If this x were 2, what would I do to these two numbers in order to get that one? Good. I did get the correct answer in the chat box. Thank you. Okay, let me do this. Let me put it in pencil. If this number were 2, what would the other one be? Okay, a few people have said it. Okay. Alex has it. So what did I do with the 15 and the 2? Somebody unmute yourself, tell me. How would I get the 13 that you guys are putting in the chat box?
Subtract them by each other.
Yep, subtract them. Okay, but we have to go 15 minus the 2. So it's very important that we use 15 minus x. 15 minus x. And I did have that answer put in the chat box. That was awesome. Okay, so the 2 was just an example to get us to the point where we knew that that was 15 minus x. If you get something like this, come back to our example or make up a number. Ask yourself, how would I get that part? Okay, because now I have enough information to solve the problem. So don't stress. I'm just going to do one triangle over the other, or one triangle equals the other. Okay, so we would have 10 over x 10 over x is equal to 20 over 15 minus x. Okay, if that did not make, okay, so this part might not make much sense quite yet. That's okay. But if the process makes sense, put yes in the chat box. If the process makes sense, put yes in the chat box. Okay, good. Nice. Okay, nice. Okay. So don't forget to put the parentheses around here so we don't lose a number. So you have 20x is equal to 10 times 15 minus x. Okay, go ahead and distribute. If you're really comfortable with algebra, there's a shortcut that you can do, but most people aren't. So I'm just going to go ahead and multiply it out. That gives me 150 minus 10x. And then if I want to, I mean, we can add 10x to both sides. Not if I want to, I have to. So 30x equals 150. And then dividing both sides by 30, x equals 5. Okay. So what that means is that my x is 5. So this would have been 5. This is 15 minus 5. So if I wanted to, if they had asked me to find that, this would have been 10. And that should make sense because this is 2 times bigger. That would be 2 times bigger. Okay. Good. Okay, so that is technically the end of our content for today. Let me ask you if there's any questions on like last week's assignments or the quiz or anything from what we've been doing. Because I'll save questions on the like this homework for tomorrow. I'm glad. I have a couple of people who are like, I actually understood this. And so I'm really glad. And this is, because this is more algebra based, and I don't have to get into all the technical geometry stuff, we can solve it without a lot of the vocabulary, okay? So I'm really glad that some of you that have been struggling are understanding this. It makes me very happy. So please make sure you're taking the quiz. A couple of people need to go back and redo it because you didn't get a very good score, but that's okay. That's why I gave it 2 tries. And make sure you're getting caught up. Please remember that there is tutoring today, 3:30 to 5:30, Wednesday and Thursday as well. Okay. Any questions? You can take the quiz before this one. If you do, email me so that I can go back and get the score because I may not go back and check. Okay, a couple of people have done that. Okay, good. All right, guys. Well, if you're good and you don't have any questions, you're free to go. A few minutes early. Hey, and you're welcome. I'm glad it was a good lesson today. But if you do have questions, hang around and we will we'll chat for a moment. Okay.